From fixing production line at BMW factory in Germany to fixing bugs in one of the most used stream processing libraries in the world. This is Confluent Developer.
A lot of application developers actually hate this idea that you have to package up a job and you submit it into a processing cluster. And so there's a team, we actually brainstormed for this for many, many weeks and tried all kind of things. And then we said, okay, we're done. Let's go for beers because we have solved the problem. And then obviously we needed to write a kip and implement it. But yeah, it was a big deal.
In this episode of Confluent Developer Podcast, I'm interviewing my colleague from Confluent, Matthias J. Sachs, about his past as PhD student in Germany and his present and future as one of the lead engineers at Kafka Streams project. Please enjoy. Hi, I'm Viktor Gamov, and I will be your host for today's episode of Confluent Developer. And today with me in my virtual studio, Matthias J. Sachs from Confluent. Matthias, welcome to Confluent Developer.
Thanks for having me. Very excited to be here.
You are probably the one of the very interesting people I spoke in my life, just in general. And also, you probably was one of the first people that I met when I was at Confluent. The first one was Chris Mata, but he wasn't in Philadelphia. And after that, somehow we got connected virtually, and I met you in Confluent headquarters in California. For those of you listeners who don't know who Matthias is, can you give us just a quick introduction to yourself? Like, what do you do? And we can continue with our conversation.
Yeah, sure. Yeah, I'm Matthias, as I said. I work as a software engineer at Confluent at the moment. I've been here for 9 years now, so it's a long time. My focus is Kafka Streams. Also worked a little bit on KSQLDB over the years, obviously. And yeah, we are still doing Kafka Streams. And so, yeah, still very excited about the project.
Yeah. In this podcast, in Confluent Developer Podcast, we kind of researching origins of different tech luminaries and tech geniuses and people who influence the technology over the year. And our first question usually to our guest is like, what was your first job? Like something that you, make some first money somehow by doing something with your hands. It's not necessarily needs to be IT job because as you might know from our previous episodes, there are a lot of people who were doing some other things rather than IT stuff.
Yeah. It depends a little bit what you define first job. I mean, some people, talked about like teenager jobs. So I thought, everybody has that, right? Being a paperboy or whatever. So I don't want to talk about that. But my first job was actually in the automobile industry. So in Germany, actually, the education system is a little bit different. And after I finished high school, was like 16, I actually started the job training at BMW as a maintenance.
I think it's a natural thing to do in Germany, right?
Maybe, yeah.
Because all the best cars come in from Germany, and like automotive industry is very strong.
Yeah, it is. Yeah, absolutely. And so I was starting this job training as an electrician for basically the assembly lines. So it's a 3-year program, and they also have this kind of education center for the trainees. But then after you spend some time there and learn some basics, then they actually really send you out into the factory, and you work with the actual teams, and learn how the robots work and the assembly lines. There's also a little bit of programming, microelectronics. So it's a very broad field, and yeah, you get paid for that. So that's basically my first job.
What year it was when you mentioned robots and all this like automatic assembly lines? What year it was there?
That was 1999.
Wow,
when I
that's
started.
Pretty cool. Yeah, that's pretty cool. So, like, since that time, did you find yourself thinking about like what would be different, how you swap back to your today programming career?
Yeah, I mean, I was always interested in programming. I actually started before that a little bit as a teenager to program. And then after I finished this job training, I was saying, well, I really would like to get into IT. And then I went back to school, and then to university, and then eventually joined Confluent. But this job training was still very interesting because of all the microelectronics you had. And yes, there was a little bit of programming as well, and you learn how microchips work. And so this actually helped me later on at the university because you already have a lot of background, right? How computers work, basically.
Yeah, yeah, yeah. That's interesting. So the hardware aspect is also was came up in different conversations with different guests as well. So you also touched on microelectronics. So before you joined Confluent, also probably another very popular job in Germany, apart from participating in some sort of automotive industry, is writing Flink, right? I know that you somehow also touched the Apache Flink back in the day, as all Germans do, I guess.
Yeah, seems to be a thing. Yeah, no, that was actually pretty cool. So as some people might know, Flink actually started as a research project at three German universities. So in the Leeds, there was
Project Atmosphere or Stratosphere?
Stratosphere, yes, Stratosphere. So that was back in the days of like big data. So the tagline was data looks tiny from up here. Well, because we're in the stratosphere. And it was cloud related. So, that is where the name comes from. And so the lead university was Technical University of Berlin. I studied at Humboldt University, actually. We were also partnering. And then there was HPI in Potsdam, the Hasse-Plattner Institute. So these three universities collaborated on this project. And then when the first PhD students graduated, they said, well, they looked at Spark. Spark was an open source project, and there was Databricks. There was kind of, well, we can do the same thing. And then they donated Stratosphere to the Apache Software Foundation and tried to get an open source project out of it. And during this donation, it was renamed to Apache Flink. Flink is, by the way, a German word, in case you don't know. It means like swift and agile, but fits with stream processing. And that's also where the squirrel comes into as a logo.
And I wear today,
very nice. Yes. And then I got more into Flink back in the days because for me that was a great opportunity. I knew the code base to some extent already from the research project, and I always liked open source. And then on the side, while I was working on my PhD, I was starting to contribute to Flink for 1-2 years. And then I became a committer at Flink. Back in the days, I actually also worked with Apache Storm. Some people might also know that. It's not really super relevant anymore in the industry. Also became a committer there. And then I joined Confluent and started to work on Apache Kafka.
This is very good. This is very cool and interesting trajectory of your developing your personal skill. What was your PhD about?
It was actually also stream processing, luckily. That was one of the fun things. I mean, most people who do a PhD work in a completely different field later on. But so the Stratosphere research project as a project was actually still focused on batch processing. It was basically, let's build a better Hadoop. But some of our university professors already said, well, stream processing is going to be the next big thing. And so a couple of PhD students, including myself, started to actually look into stream processing already. That was the main reason why I worked on the Spark as well, because the rest of the project was focused on batch processing. Not Spark, Storm, sorry.
Storm.
And then later on, Data Artisan made the pivot from batch processing to stream processing with Apache Flink. And so I then had already the background with stream processing. And so there was basically two topics in the PhD thesis. One was optimizations, trying to figure out how you deploy your data flow program. So how much parallelism do you need for each of the operators, and try to build some kind of a cost model. And then the other part was actually then later on about Kafka streams, because my original plan was to finish my PhD before I joined Confluent. But obviously plans never work out. So I actually was not working on my PhD for like the first year when I was at Confluent because, well, you move from Germany to the US, everything is exciting. And the PhD is not important anymore for like a year. And then I came back and then we were already deep into Kafka streams and I needed more content. And then I was saying, or proposing to my advisor to say, well, we work on this Kafka streams thing. That's very interesting. I would like to write one chapter about that one. And he agreed to that one, and so one chapter is also about Kafka streams.
Yeah, this is super cool. This is I didn't know about this. How deeply you involved with this, with your life interconnected with Kafka streams. So one of the things that we like to know on this podcast is that I assume there would be some interesting things to learn from you about Kafka streams, but what would be, in your opinion, in your own words, what would be the most challenging or more interesting problem that you solve, or you didn't, or you're still working on this?
Now a quick word from our sponsor. Confluent Developer, the podcast, is brought to you by Confluent Developer, the website, which has everything you need as a developer of data streaming systems. And it's completely free. We've got curriculum, hands-on exercises, executable tutorials, the online data streaming engineer certification, also free, a way to find a meetup near you, those are free. Everything is there. I really want you to be successful in your journey as a data streaming engineer, and this is the site that has what you need. Check it out at developer.confluent.io. That's developer.confluent.io. Now back to the show.
Yeah, most difficult is tricky. I was thinking about this, and
difficult,
one thing
challenging, interesting, fascinating, something kind of like that, sparks every time when you're thinking about this.
Yeah. But one thing we learned, and I think it's very interesting, is API design in Kafka Streams, because it's a library, and it's something you obviously do not learn at grad school. And that also goes to being backward compatible. So if you put out a library like Kafka Streams, and now we have like tens of thousands of developers out there using it, right? And you want to change stuff, you cannot really just break people. And being backward compatible is a huge challenge. It still is. And also API design, because you need to guide the user how to use the library. And we had this large rewrite we wanted to do at some point because we faced a problem. So Kafka Stream started out as a very small library. And obviously over time it grew and we added more functionality.
So let me quickly ask you. So why it was library? Because at that time we had the systems like Spark, Flink is getting some traction. We had Samza that was available in LinkedIn that also was the system that was supposed to be running cluster. What was the thinking process behind this? Like, why library? Why not continue to build clusters? Like because Hadoop was very influential for the systems, including Storm, Heron. That was kind of like a next generation after Storm, or Heron, probably Heron. I don't know.
I think Heron. So, I'm not sure.
Yeah, Heron.
That actually goes before I joined Confluent. And it was actually learning from Samza. So a lot of people at LinkedIn who worked on Kafka also were involved in Samza, including Jay. And one thing I learned from Samza is that a lot of application developers actually hate this idea that you have to package up a job and you submit it into a processing cluster. And so based on these learnings, and it was also a very hot topic back in the days about deploying microservices. So Jay and others, I'm not sure exactly who was the core person pushing that, said we want to build Kafka streams differently as part of a library to change how you can deploy your application. Because if you build it as a library, then also runtime and everything is packaged in the library. And when you build a microservice, you can just deploy a regular Java application. So your deployment model doesn't change. And said it was much more appealing for developers who build microservices.
And when the thing started, I guess it was still Java 7, right? Everything started before this. Speaking about API and speaking about backward compatibility and some of the things that's available right now in Kafka streams and available specifically in Java these days. And people thinking about these Java util streams as a influence in some case, but you probably have some stories to tell about like how this design of this API came before Java util streams was a standard for processing of the the performing operation on the collection.
Yeah, absolutely. No, and I mean, the Kafka Streams DSL, in fact, is inspired to some extent by the Streams library. I mean, when you write a DSL program, right, you say builder.stream.map.filter or whatever. So it's this kind of chaining of operators together, and that is very much inspired by the Java Streams design, which was already out there. We couldn't just use it, obviously, because we were still on Java 7.
Yeah, it was not there at the time, right? But you need to make sure that some of the APIs and some of the interfaces that were available in Kafka Streams before also will be compatible with Java 8.
Yes, absolutely. So, for example, there's a lot of shenanigans in Kafka Streams still. For example, when you define a processor or something like that, Kafka Streams defines its own processor supplier interface. And the main reason is, back in Java, there was no lambdas. So we had to do this ourselves. Mm-hmm. And it's still backward compatible to the lambdas, right? It can be used as a lambda with Java 8, but back in the days, there was no such thing. So we had to invent it. Similar thing, actually, for Kafka Core. Kafka used to have a Kafka future. That was the same thing. In Java 7, there was no concept of futures. So Kafka re-implemented futures manually. And then later, when we upgraded to Java 8, then they adopted.
Future was there, right? So there was no completable future that was available in Java 8 that allows to kind of like subscribe to, when the sync process will finish to do stuff, you can get notification. But future was there in Java.
Maybe to some extent, yeah. Yeah, maybe. But yeah, so basically it was not completed, right? And Kafka basically was saying, well, we re-implement a couple of these things manually, and you can still find them in the code base. And so they're still there, yeah.
Yeah, no, this is one of the things that still bothers me, and I refusing to call it DSL, because for me it's just like a fluent interface, how I like to call it. Every time when you're writing kind of like Kafka Streams, like a builder type of the topology builder, I'm refusing to call it DSL. For me, it's still just a fluent interface.
Yeah, it is. Yeah, it is both, right? It's not wrong.
I don't know. Like it's when I was talking to people and explaining this, for me, DSL is more something that would not have any type of kind of like programming language vibes. Like SQL for me is DSL. Something like that. Even. You can think about when we write down topology of Kafka streams, it's kind of like text representation. This you can use as a DSL, kind of like describing this. But it's a question to purists. Write down in the comments what do you think about the naming of APIs, and if you're calling fluent interface of Kafka streams a DSL, and because there's a processor API, there's a DSL. So you were talking about the API design. So what was the challenges there? Like what's the first thing what's the most interesting thing that you've done that worth mentioning in this show?
Yeah. So basically, Kafka Stream started out with the DSL, and we had a couple of operators like filter and map and stuff like that. And then we added more functionality, for example, to say, well, you should be able to give a name to the processor, or you should be able, when you read from a topic, to specify kind of properties, what timestamp extractor you want to use, what serializers you want to use. And so what happened is we just added overloads for the same method. Mm-hmm. But then the problem was that we immediately or quickly actually had a problem that we had too many overloads, because every time you add a new parameter, right, you want to make it like optional. But then you have all these combinations of things you want to allow people to pass in, that they don't have to specify all of them and pass in a lot of nulls. So
Correct.
when you have like one parameter, it's easy, right? It's either there or not there. If you have two parameters, then it gets a little bit more complicated. But when you add like 3 or 4 parameters, you actually have the problem that the number of overloads you get grows quite radically.
Yeah.
And so it really explodes in your face and it becomes
Yeah,
like
but in this
unbearable.
case, we know the pattern called builder that should come into play and come handy, right? So that's
Yes,
what
but
the
that's not so easy to be done. And that was exactly what then we were kind of saying, because in the end, if you do this builder thing, right, then you kind of break the Fluent API. So a very straightforward way would be to say, well, you do like a builder.stream, but then you don't really have a case stream yet, because now you need to also call this kind of, with statements to pass in all the properties. And then you need to call a build, and then you get a case stream. And now you can do a filter with build. This
yeah.
kind of feels ugly, right? And it also makes the
Yeah, because
DSL very
in this
long.
case, you cannot have this as just one consequent, like one call after another. You need to have a
Exactly,
still
because you want to
you're
do
breaking this.
filter, map, join, right? And not all
Yeah,
these intermediate builder calls in
exactly.
between. And
So I
that was
think
exactly the
it's
challenge.
not even it's not like you bring in like a fluency. You bring in this like a function approach that we want to apply. It's kind of like, yes, we do have this description of this job, but essentially that's what we're building, like description. It's not actually doing anything until it will be running inside the Kafka Streams application, and functionally all this with they're not relevant there. They're not supposed to be there. They're not adding anything to mental model of the processing.
Exactly. You want to have this Fluent API. At the same time, you don't want to have all these overloads that you can avoid with the builder pattern, but the builder pattern breaks your Fluent API. So what do we do? And so there's a team, we actually brainstormed for this for many weeks and tried all kind of things. And eventually we come up with this idea that we have nowadays, where we basically say, well, we have the mandatory arguments, and then we have a configure argument. And then we apply the builder pattern to this configuration object. So if you know the Kafka Streams DSL, if you say, for example, I read from an input topic, I do builder.stream, I pass in the name of the topic, and then I have a helper object that is called consumed. And then this consumed thing now is actually assembled via the builder pattern, where you say consumed with 30s, with timestamp extractor, with this, with that. But now you basically have a completely different pattern, and this is a much better API. And yes, the interesting part was really when we I remember this very well. We were sitting in this meeting room in Palo Alto. The whole team was there, but it was also rare because our team was distributed all the time. And then once in a while, you just need a whiteboard to figure it out. And we did this session. It was like 2-3 hours. I can't remember. And, everybody was drawing ideas about the design on the whiteboard, and we discussed. And I was also still super junior back in the days. And, and then we came up with this idea, and it immediately clicked for everybody. And then we said, okay, we're done. Let's go for beers because we have solved the problem. And then obviously we needed to write a KIP and implement it. But yeah, it was a big deal.
And also, it's not the problem with the API design is you cannot rely on someone else will do the job for you. For example, if you're writing this library that will be relying on dependency injection, right, Spring, so that's already someone will solve this for you. And I think that with this consume object, you also relying on the standard configuration mechanism, because you can define something on property files and it kind of sort of will work until you need to use different serialization. If you're changing the object, you need to have different third days. Especially the things will change if you're using non-Java serialization and all these kind of things. But yeah, it's totally understandable. And honestly, when I started learning Kafka Streams and when I was building my apps, I actually enjoyed a lot spending time in this DSL Fluent API world without me needing go like very deeper into processor API. I probably implemented processor APIs, I don't know, like 3 or 4 times in my life. One of the things is one example for the book for Kafka in Action, when I was telling, okay, so you actually can use the processor API to do a lot of things, and because of the built-in like exactly one processing, you can perform atomic kind of like a transaction, like monetary transaction example that I was showing that how the processor API can be used in this case. And yeah, that was great API to use, and also based on my experience, you in the team with Kafka Streams, you have a little bit more flexibility or freedom in terms of moving a little bit faster in terms of APIs that you can implement, comparing to like bigger brother with the producer and consumer API. Those are still, I don't think they're changing much from perspective of like public APIs there. But first of all, before version 2.0, Java 8 was not the thing, so you had to, with the 2.0 was released, you need to comply with this single method interface paradigm. And the cool thing, it was working out of the box. The reason why I remember this, and the reason why I kind of like can relate so much, one of the previous podcasts that people might heard, I work in the company called Hazelcast, and open source project called Hazelcast. And our influence was highly influenced by Java collections. Hazelcast just exposed the Java util map style. So that's why for us, we wanted to very much have this feeling that everything you do with map, just change the way how you initiate this map. Instead of doing new hash map, you're saying that like Hazelcast get map or something like that. And that's why for us, like integration with API also was very important, and the integration for Java 8 was a big deal, at that time.
Yeah.
Are there
no.
any
I mean,
other cool things that you want to talk about in this angle?
yeah, there's one more thing maybe to mention. Once in a while, you actually also try to do something, and you might break people without realizing it. So in Kafka Streams, we have this high-level object to configure the job that is called the streams config. And to some extent, it's kind of a helper only. And at some point, we thought, well, we should maybe get rid of it. It doesn't really make too much sense to have. And when you create your Kafka Streams client, you can just always pass in a properties object, and you're done with it. Mm-hmm. And we did a kip for that. And we deprecated the old constructors in Kafka Streams to get rid of streams config as a parameter and to only accept properties files. Mm-hmm. And that was released. And again, this comes back to like backward compatibility, why it's so important, right? We only deprecated it. We didn't remove it, so it was still there. And then like 6 months later or whatever, somebody reaches out and said, hey, by the way, you deprecated this. This is actually very important for dependency injection. Because if we only have the properties file, dependency injection doesn't work anymore. It depends on having a concrete class like streams config that can be used to inject the configurations. And then they flagged this to us. And then we basically undeprecated the old API with another kip and said, okay, we keep it to make this user happy, or also users who use actually dependency injection, to basically not break them in the future.
It's, I think it's I cannot explain this, and maybe one of the listeners can also give me an idea, but for some reasons, at Confluent, we are not very much, in favor of certain frameworks, and I'm a huge fan of the Spring, and I spend a lot of time in their ecosystem and helping people building Kafka applications with Spring. And there was a lot of good implementation. I have strong opinions that the best today, if you want to use Kafka Streams with event-driven microservices, you're not using this in a kind of like by itself. You're using this either with Spring or using this with Quarkus. If you're in Java, there's no reason for you not to, because those frameworks doing a lot of work, especially in the configuration space, and providing you with the nice way how certain things can be injected. And that's probably like someone from there the ecosystem came in and saying, hey, like we use this in our projects, and I wish. But again, it's kind of it's already the water under the bridge. All these things already the questions of the past. There's still great integration for other frameworks with the Kafka streams and Spring and Quarkus. They're doing a great job to integrate this. And yeah, what are you exciting for in say next few releases that come in? I understand right now there's a lot of kind of sort of not the maintenance, but let's call it the quality of life things. That's something that framework will benefit, that maybe will not be exposed through certain APIs. Things with the supporting with the new rebalance protocol, things that will be there. What's your personal excitement for the next releases or next APIs?
Yeah, sure. Yeah, I mean, there's still a lot of other things going on where we basically want to enrich the DSL with new functionality. But yes, Kafka Streams to some extent is kind of feature complete if you wish. And so we invest more into the runtime at the moment. And yes, KIP 1071 that we're working on at the moment is obviously the most exciting one we have, integrating with this new rebalance protocol, as you said. So with KIP 848, this was introduced for the Kafka consumer, and it is already GA since Apache Kafka 4.0. But the way it was built for the consumer doesn't work with Kafka Streams. And so we basically proposed a new KIP to extend this functionality for Kafka Streams. We released an early access with 4.1 release in Apache, and we hope we can call it a GA with 4.2. So we are working on that one. But this is a whole another episode where you might need to invite somebody else to talk about this.
Yeah,
because
exactly.
This goes down the rabbit hole.
I really want to talk more about the quitting layer, and maybe you say the feature complete, but I don't believe I think there's still a lot of things can be done on the quitting layer. Kafka Streams has this unique functionality that is not available in other frameworks. For example, in Flink, you need to do a little bit hoops in order to do this. It's a quitable state. So it's a stateful stream processing application. You have ability to tap into some sort of like intermediate steps or even final steps. You can materialize it and keep it in memory, or keep it in the form of by default RocksDB tables and things like that, and providing ability to query this. I think it's very unique, and turning your microservices in more like a query engine, that potential, and bring in the real DSL, maybe kind of like something with SQL, or at least something that will understand not only key value query capabilities, but it's a whole another kind of like a whole another research, right? Because it will require when you trying to query something that is not key, you going into the route how you can query this faster. So you going in the route deserialization, indexing, whole another route. And I understand why Kafka Stream doesn't do this type of things, because it's also we're trying to keep this lean enough so it will not introduce some weird external dependencies, so it will not be bloated with the things. But it's definitely possible to use Kafka Stream as a framework for building that type of system. Like KSQL, that was a good example of the system that used Kafka Streams to build something more, so like some more streaming database. And yeah, that's kind of like my my personal probably topics that I want to explore in the future episodes. But Matthias, do you have any inspirational words for people who listening this, or maybe like working on some challenging things? What's your, say, like a mindset of approaching this type of problems? You spent you basically came from academia into kind of like applied software engineering and the world of APIs, and definitely kind of like was interesting interesting last 10 years. Any inspirational words for our listeners before we say goodbye?
Yeah, sure. I mean, it depends a little bit what you want to do as a software engineer. So for me personally, I always wanted to become like a deep expert in one small area and not become an all-rounder. And both is totally valid, right? And if you really dig deep into something, then one thing you need to do is rinse and repeat before it really clicks. And so it takes a long time. And that is what I really recommend for people, right? I mean, don't basically say, oh, I've read something about topic X and then I know it. No, go back to it a year later, go back to it 2 years later. And every time you reread these things, you learn something new and you get a different angle, how you actually explain it. And I think that is super, super important to become a deep expert. Even if you think you know it, still read how somebody else explains it. Read a blog post about it. Or maybe even write a blog post about it, because it also shapes how you think about it. I think if you want to become a deep expert in something, helping others by explaining stuff helps you personally to grow much more than the person you're explaining it to, because when you have to explain it, you need to think about it much deeper. And so actually writing blog posts, doing talks or something like that, I think is a very good vehicle for yourself to dig into these things more and more and more and find out all the small nuances that you might miss otherwise.
Matthias, thank you so much for being a part of Confluent Developer. My name is Viktor Gamov, and as always, have a nice day.